Hello student, once again welcome you all by Ashwamit coaching class, myself Samadhan Patil, and today we are going to discuss about the exercise. The examples depend on the irrational and rational number. Okay, so in the previous lecture we have seen about the rational and irrational. So how we make a difference, how we make a difference between irrational and irrational with the help of decimal representation of real number that we have seen, and also we have discussed some examples um, based on the decimal representation of some rational numbers. Okay, now today we will discuss the exercise, and from that we'll try to understand some more examples on that concept. Okay, so let us start. Now the first example is write the following decimal form. Write the following in decimal form and say what kind of decimal expansion each has. Okay, so we have to write some uh, decimal form here, following in decimal form, and what kind of decimal expansion it is. Okay, either it is recurring or terminating or non-terminating, non-recurring, that we will see here. Okay, that we have to say. So first is 36 by 100. Okay, so 36 divided by 100. Let us find the decimal expansion of this. Okay, now 36 divided by what? 100. Now so we cannot divide 36 by 100, therefore take 0. Okay, and therefore 0 point, so you know the division, so we just divide that 0 point. Now we get this 360. 100 into 3 is 300. Okay, so 300, 100 into 3 is 300, and therefore 360 minus 300 is what? 60. Okay, so here what I get, it is 60. Now again we cannot divide by 100, therefore take again 0, and therefore we get a 600. 100 into 6 is 600, and therefore now 600 minus 600 is 0, so remainder is 0 here, so we can completely divide by here 100. 36 divided by 100, so we get 0.36. There is no further remainder, so now remainder becomes 0 here. So if the remainder is 0, that decimal is terminating. Got it? Okay, so see here, 36 by 100 is 0.36, and therefore what? Remainder is 0, and this expansion is what? Terminating. So if remainder is 0, the expansion is terminating. Okay, if we get certain blocks, okay, if we find certain blocks are repeating, that expansion is recurring. Okay, and non-terminating, recurring, like that. Okay, so let us see the second example, 1 by 11. So 1 is divided by 11 here. Now we cannot divide 1 by 11, take 0, we get a 10. Okay, once again we cannot divide 10 by 11, so therefore again take 0, 0 0.0. Now we get 100 here, so 11 into 9 is 99, so 100 minus 99 is 1. Okay, so take zeros again, take 0. Again we cannot divide 10 by 11, so take another 0, so this is 0 here, and now again we get 100. So 9 into 99, 9 into 11 is 99. 100 minus 99 is 1. Again we'll get 100, take 0, 99. Okay, so in this way we can, this division is goes on, so remainder is 1. Every time is remainder is 1. This processing uh, unending. Okay, this process has no end, so we get 0 9 0 9 0 9 0 9, so that here in the quotient. So therefore here we cannot completely divide 1 by 11, so we get 0 or 9 0 9. Every time we get a remainder 1. See this, here the remainder is 1. Okay, here the remainder is 1, here the remainder is 1. So again we take 0 here, we cannot divide 10 by 11, we cannot divide 10 by 11. Again we take 0 here. Now we get 100, so 100 and 11 into 9 is 99, so 0 9 again is there. So every time we get 100 minus 99 is 1, 100 minus 99 is 1, so that process is goes on. So therefore here 1 upon 11 is 0.90, 0.0909, so on. Now if you observe, 09 is repeating here, so if this block 09 is repeating here, so that's why we have made the bar on this 09. See, this block is repeating every time, 09 09 09, once again next is 09. Okay, so this block is repeating here, so we just take the bar on the head of 09. Okay, and now remainder is 1 here, 1 comma 1, in every stage remainder is 1. So this is 1 1 1, and in also next step we'll get remainder as 1. Okay, also in next step we'll get remainder as 1. So we made them 100 so on. Okay, and therefore this expansion is what? This expansion is non-terminating repeating, non-terminating repeating. Okay, so this expansion is not terminate here, and but it repeats, so therefore not terminating repeating. Got it? Okay, so same. Now the next is 4 as to 1 upon 8. Now 4 as to 1 upon 8 is simply what? 4 plus 1 by 8. Okay, 4 plus 1 by 8, as you know this number. Okay, how to find the number. 4 into 8 is 32, 30 into 2 into 32 plus 1 is what? 33 by 8. Now here we just divide 30, not 36 actually, this is 33. Okay, this is not 33, sorry for this is 33. Okay, so we just divide this 33 by what? 33 by 100, not 100, it is 8. Okay, so this is not 100, 8. This is the writing mistake. So this is 33 divided by what? 8. Now if we divide 33 by 8, now 8 into 4 is 32. Okay, so 4 is there. Now 33 minus 32 is 1. Okay, so we make 0 because we cannot divide 1 by 8, so that will take decimal point. Okay, so here then 10 minus 8, 10 minus 8 is nothing but 2, make it 20. So therefore uh, 8 into 1 is 8, so 10 minus 8 is 2, 20. So now 8 into 2 is 16, so therefore 16, 20 minus 16, 8 into 2 is 16, 20 minus 16 is what? 4. So we get a 40. Now we can completely divide 40 by 8. 8 into 5 is nothing but what? 40. Okay, you'll get remainder 0. So once the remainder is 0, then it is terminating decimal. Okay, so here 33 by 8 is nothing but 4.125. Okay, and remainder is 0, therefore expansion is what? Terminating. Got it? Okay, now next is 3 by 13. Here see 3 by 13 is nothing but so we cannot divide 3 by 13, so therefore take decimal 0. So 30, we get 30 here, and therefore what? 30, if we take 13 into 2, we'll get 26. So 13 into 2 is 26, 30 minus 26 is 4 here, so again it become 40. So 40, 13 in the table of 13 we'll get 39. Yes, 13 into 3, so next number is in quotient is 3, so 13 into 3 is 39. So 40 minus 39 is 1. So here we cannot divide, we get a 10 here. Okay, so take a 0, but we cannot divide 10 by 13, so therefore take another 0, so we get a 100 here. Now that's why we have taken 0 here, because we cannot divide 10 by 13. Okay, so that's why we have taken 0 and 0 here, one more extra 0, and now we'll get 100. Now which is the nearest number to 100 in the table, which is less than also in the table of 13? Yes, it is 91. Okay, so 13 into 7 is 91. 100 minus 91 is 9, we'll get 90, take 0. Okay, so which number is nearest and also less than 90 in the table of 30? It is I think 78. Okay, so yes, it is then 13 into 6 is 78. Okay, 13 6, we get 13 into 6 is 78, and therefore 90 minus 78, so this 6 is here. Okay, so therefore 90 minus 76 is 12, so we'll get 12. So take a 0, we'll get 120. Now 117 is nearest number to 120, so 13 into 9 is 117 actually. So if we take the subtraction, we'll get 3, take a 0, it become 30, again we'll get 26, and same procedure we'll get from this. Okay, again we repeat the same procedure. Once if you come here up to 30, so we'll have to repeat the same procedure. See, we are going to repeat the same procedure here. Now 26, this 30, this box again will get here. Now the next box is here, so 1 is there, so again the same box will get here, and after that the same procedure will get after this. Okay, so therefore this is what this is 0.23076923. Okay, 3 by 13 is 0.23076923. So if you observe, so this block actually repeating. After this 2 3 again we'll get 0 here. Okay, then 7, then 6, then 9 again. Okay, again this block is repeating. Again the same block we'll get after the expansion. Okay, so particular box is repeating here. So 3 by 11 is nothing but 0 point bar 230769, and here remainders are 4 1 9 12 3 4 1 9, again same. Okay, so these remainders are repeating here 4 1 9 so on, and therefore the expansion is what? Non-terminating repeating, because this block is repeating one again and again. 230769, 230769. That's why this is what repeating, and the expansion is not terminate here. Terminate means what? Remainder is 0. So if you see in uh, there is no 0 in any of the term. Okay, so we'll not get 0 here as a remainder. Every time we'll get either 4 1 9 12 or 3. Okay, that's why this is non-terminating. So this division is not terminating here, decimals are not terminating here. So but some block is repeating, therefore it is non-terminating repeating. Got it? Okay, so see example number 2. You know that this 1 by 7 is 0 point bar 142857. So we have seen this actually in the previous lecture. So what is the expansion of 1 by 7 in detail by dividing 1 by 7. So can you predict what is the expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are? What are the expansion of this? Okay, without actually doing the long division? If so, how? Is it possible to divide or to find the expansion of all these 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 using the expansion of 1 by 7 without division, without doing actually the long division? Okay, and if it is possible, how? Yes, it is very simple, because we can write, see, we can write this 1 by 7 2 by 7 as 2 into 1 by 7, 2 into 1 by 7. Okay, and this 3 by 7 is 3 into 1 by 7, and so on. Okay, with the help of this and with the uh, using the given expansion of 1 by 7, we can easily find out the expansion of these all things, all rational, without actually doing the long division. So how it is? See this. So given is 1 by 7 is equal to this 0 point bar 142857. Okay, now let us see the expansion of this 1 by 7. It is actually division actually that we have performed in the previous lecture. Now see, 2 by 7 is nothing but 2 into 1 by 7. If you see, 2 is divided by 7. Now we directly come to this block here. Okay, so we just directly come to this, because we get 2 here. So 2 into so we cannot divide 2 by 7. Okay, so 2 divided by 7 here. So our division is actually start from here. And therefore what? So in the expansion we get our quotient is start from 0.2857 and again 14 after this. Got it? Okay, so there is 285714. The same procedures are in the next steps. Okay, after this okay, so your division 2 by 7, the decimal expansion, the actual division of 2 by 7 is start from this 20, this block 20 and 40. Okay, so the quotients also start from 285, 2 start from 2, and the next are same 85714. Okay, so therefore what, therefore the expansion of this 1 by 7 is what, 0.285713, sorry 5714, so that 14 goes into the last. Okay, now secondly 3 by 7, 3 into 1 by 7. So if you go to 3 into 1 by 7, so here what happened, so your decimal expansion actual division is start from here, 3 is divided by 7, so obviously the quotient, in the quotient we just start from 4. Okay, so therefore 42857 into 1 is at last. Okay, like this. Okay, if you see the 4 by 7, 4 into 1 by 7 here, so our expansion is 4 is divided by, where is 4, this is your 4, see, and our expansion is start from here, 4 by 7. Okay, and therefore 4 by 7 means what, 4 into 1 by 7, and therefore 35, so your quotient is start from 57, so this is 571428. Okay, first 57 and then another numbers after that 57, 571428, like this, 571428. Similarly if you take 5 by 4, 5 by 7, so where is 5, this is your 5, see, and now our division is start from here, so 7, so your quotient, first number in the quotient is 7, 7, and after that 14285, see this is 7, 14285 after that. Okay, next is 6 by 7, where is 6, find out 6, this is your 6, see your division is start from here, 6 is divided by 7, and therefore 60 here, 56, 7 into 8 is 56, so your quotient is start from here, 85714, 85714. So without finding actual division of all this, we can easily find out the division of 2 by, the decimal of 2 by 7, 3 by 7, 4 by 7, 5 by 7, and 6 by 7. Got it? Okay, let us see the third example. Express this 0.9999 in the form of P upon Q. Are you surprised by your answer? With your teacher and classmate, discuss why the answer is make sense. Okay, so it is very simple to express this 0.99999 in the form of P upon Q. Okay, and but only the thing is what, why are you surprised by the answer? So it is, we can give the answer of this once if I find the P upon Q. Okay, so what is P upon Q, that we will see. So now see this, take x is equal to 0.999 that we have already seen. To find out the number decimal expansion in the form of P upon Q, so we just take x is equal to given decimal. Okay, so x is equal to 0.999, so we just take it as zero point 0.9 bar because one digit is repeating here. See here we have seen in some previous lectures, if one digit is repeat here, we just multiply by 10. Okay, if two digits are repeating, so we just multiply by 100. Okay, and if three digits are repeating, we just multiply by 1000, that we have seen in previous lecture. Now here only one digit is repeating, therefore we just multiply by 10. What I get here, 10 into x is equal to 10 into 0.9999, so 10 into this 0.9999 into 0.999, so on. So now one digit is before the decimal. Okay, so therefore what I get, 10x is equal to 9.999, isn't it? Because we just multiply by 10. If I multiply by 10, so one digit before, 19 before the decimal, so therefore 10x is equal to, we can write this 9.999 like this, 9 plus 0.999. If you take the addition of this, we will get this. But what is this? 0.999 is nothing but x. See that we have assumed, we have taken. So therefore 10x is equal to 9 plus x. Now x goes into this side, it become minus. Okay, so therefore 10x minus x is nothing but 9. And what is 10x minus x? It is nothing but 9x. 9x is equal to 9, and therefore x is equal to what? 1. X is equal to 1. This is the value of x. Okay, so see, x is a rational, obviously it is in, we can write that 1 in the form of P upon Q. So here 1 can be written as what? 1 can be written as 1 upon 1. Okay, so this is in the form of P upon Q, where P is 1 and Q is 1 here. So see, X is 0.999 and X is also 1. How it is? Okay, so that's why in the example they are asking, uh, are you surprised by your answer? Okay, so definitely you will surprise with this answer, because our X is 0.9999 and what I get the value of X, it is 1. Is they are same? Yes, they are same, because as we here we are surprised to get the integer 1, because 0.9999 goes on forever, so there is no end for this 9. This is go forever. Okay, no gap between, and if we go, if that 9 goes forever, there is no gap between 1 and 0.9999, isn't it? So they are approximately same, they are same, and hence the answer is 1. So therefore X is equal to 0.999 and X is equal to 1 are approximately same. Got it? Okay, because there is no gap between in these two, there is no gap in between 1 and 0.999 because that goes on forever, that nines are goes on forever. So the gap is, if we take the difference between these two, it is point zero 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 zero, so on, it is 1. So there is a difference of point not, it is very negligible difference. Okay, so that difference is very negligible, we just neglect it, and therefore we just take X is equal to 1. Got it? Okay, now what can the maximum number of digit in the repeating block of digit in the decimal expansion of 1 by 17? Perform the division to check your answer. So we now perform the division of 1 by 17. Okay, so let us see that what is the division of 1 by 17. So the 17, 1 is divided by 17, so here again we cannot divide 1 by 17, so take the 0 point, so we get 10 here. Again we cannot divide 10 by 17, again take 0, so 0 0.0, we get 100. Now 17 into 5 is 85. Got it? So 17 to 5 is 85, and therefore here 100 minus 85 is 15. Take again 0, we'll get 150. Okay, so 150, so which one is nearest number to 150 in the table of 70, but it is also less than 150, it is 136. Okay, 17 into 8 is 136, 150 minus 136 is 14. Okay, take again 0. Okay, now so we get 140. Now 17 into 8 is 136 once again. Okay, 140 minus 136 is 4. Take again 0. Okay, so we get 40. So 17 into 2 is what? 17 into 2 is 34. Okay, see here, uh, this 5 for 85, this 8 for 136, this 8 for again this 136, this 2 for, okay, 34. Okay, 34 into 17 is what? Sorry, 17 into 2 is nothing but 34. Now what is 40 minus 34? It is 6. We get a 60. Okay, and now next is 70 into 3 is 51. Got it? So 70 into 3 is 51. So 60 minus 51 is what? 9. So take 0. We get 90. Okay. So then after that 90. So 85 here we have. Now again 5 into 85. Okay, so 5 into 17 is nothing but 85. See here, so 5 into 17 is nothing but 85. So 90 minus 85 is 5. Again take 0, we get 50 here. So 50, again 17 into 2 is nothing but 34. Okay, and therefore what? 50 minus 34 is 16. Take 0, 16, 160, we get 160. Now 17 into 9 is nothing but 153. Okay, as you know this division, I just revised that. Okay, and you know how to divide that number. Okay, 153, then 160 minus 153 is 7, we get 70. Okay, so 70, then 68, actually 4, 17 into 4 is nothing but what, 68 here. Okay, 70 minus 68 is nothing but 2, we get 20, and therefore what, 17 into 1 is nothing but 17, 20 minus 17 is 3, take 0, again we get 30, and therefore what, 1 into 17 is nothing but what, 1 into 17 is nothing but 17. So 30 minus 17 is nothing but what, 13, again we'll get take 0, we get 30, 130. So and therefore what, it is 17 into 7 is nothing but 119. Okay, 130 minus 119 is 11, take 0, we get 110. So 7 into 6 is nothing but 102. Okay, so 110 minus 102 is nothing but 8, take 0, we get 80. So now here it is 17 into 4 is nothing but 68. Okay, 80 minus 68 is 12, take 0, and 17 into 7 is nothing but 119, so we get 1 here. See, remainder is 1 here. Finally remainder is 1, and the same procedure is start from here. See, then after that there is no, we cannot divide 1 by 17, therefore we take two zeros again, this 0.5 is there. Okay, so on. Now this is repeating block, we can take the bar on this whole digits. Okay, whole block. So therefore what, 1 by 17 is equal to 0 0.588235 294117647. Got it? Okay, so in this way we can find out the expansion of this. Okay, and we get the decimal expansion, so the we get the repeating block of the digit in the decimal expansion of 1 by 7. So this is very huge block. Okay, so as usual. Okay, next is write the three numbers. This is also interesting. Write the three numbers whose decimal expansion are non-terminating, non-recurring. We have to write the three numbers, as we know that every irrational is non-repeating, non-terminating. So write the three any irrational numbers. Okay, so solution is what, all irrational numbers are non-terminating and non-recurring, that we know, and therefore these three numbers are root 3, root 2 and root 5. This is simple. Okay, non-recurring, non-terminating means irrational, and rationals are terminating or non-terminating, recurring. We have discussed already in the previous lecture. So if you don't go through, if you are haven't go through that lecture, just go through the lecture so that you can understand the concept of rational and irrational. See, rational means non-terminating, non-recurring, irrational means non-terminating, non-recurring, and rational means either terminating or non-terminating, recurring. Okay, so this is the difference between that. Next is to find the difference between the rational and find find three different irrational numbers between the rational number 5 by 7 and 9 by 11. We have to find the three irrational between what, these two rational numbers. Okay, first of all we just find out the decimal expansion of these two, and then it is very easy to find out the irrational between these two. Okay, so the rational we can easily find the decimal expansion. Okay, you know how to that. 5 by 7 is can be written as 0.71428 bar 5 bar, and 9 by 11 can be written as 0.81 bar. You know how to find this decimal expansion. Previously we have seen some example regarding this. Okay, so you can easily find out the decimal expansion of these two. Now, so just focus on 0.714285 and 0.81 bar. Okay, so we have to find the irrational between these two. Okay, so whatever the irrational between these two, irrational means what, irrational means non-terminating, non-recurring. Okay, so whatever the number, so irrational means what, non-terminating, non-recurring. This word is very important. So you just keep in mind every time about the irrational. These are what? Non-terminating, non-recurring. Okay, so these are non-terminating, non-recurring. So because we can find out the irrational with the help of these two words, non-terminating, non-recurring. Okay, so once if I got the two rationals, their decimal, so whatever the number you can write in between these two, that will be the irrational. So just take care about their decimals. Okay, so three rational numbers between this three rational between the rational number 5 by 7 and 9 by 11 are, see, the first is 0.72301, 3001, 0001. You can take any after that. 72 after 71, so you can write the next number after 71. So there is no 71, so you can write 715 also. Okay, so 72 it is better, 73 is also, 75 is also you can take. Okay, but it is that expansion is non-terminating, non-recurring. This is important. Non-terminating, non-recurring. See here, 0.72300100010001 and so on. This is non-terminating. Also, this is non-recurring. See, no one, there is uh, no single block which is repeating. This is go along. So once again, see, this is 0.7, but make sure that that number is less than 0.81. So that number should be less than 0.81 and greater than 0.71. That is a very important thing. Okay, so there they are the actually in between these two. You can write any decimal after 72. You can write any decimal after 71. Okay, so any digit after 72, that for example I have taken 3001001001 like this, and 7407500501001000. You can take any digits after 74. Okay, and also third is C, 0.78. See, this is less than 0.81, so 780 0.78 078 000 075 and so on. That dot 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 means that is non-terminating and no block is repeating. So it is very simple to write the two yeah, so irrational number between any two rational. So one more thing is here, there are infinitely many irrational between any two rational. We have seen that. Okay, classify the following number as a rational or irrational. So classify these. See, it is very obvious that root 23 is irrational number. So this is irrational number. This is prime number actually. So we cannot find the further factorization of this. So this is not the square of any number. So this is irrational. Okay. Now root 225, 225. This is a square of 20. So this is a square of 15, and therefore this is not irrational. This is a rational number. Okay, so second one is a rational number because root 225 is nothing but what? 15 plus minus 15. Okay, so this is terminating decimal 0.3796. There is no bar on this, and this is terminating decimal, therefore this is also rational. Okay, so with the help of definition you can easily classify them. Okay, 0.7478 see here, if you observe, this block is repeating, here 478, again 478, again you can write here 478. Okay, so this is what? Non-terminating but repeating. So if the decimal is non-terminating repeating, then we can call it as what? Rational. This is also a rational number. Okay, and last one is C. Obviously this is non-terminating, non-recurring, so this is irrational number. So there is no block which is repeating again and again, and this decimal is goes on forever, so therefore this is irrational number. Got it? So we can easily classify them into rational and irrational. Okay, this is for homework. Look at the several example of rational numbers in the form of p upon q, where p and q are integers with no common factor other than 1. So means we have to take p and q are prime numbers, okay, and having terminating decimal representation. So can you guess what property q must satisfy? Okay, so check for this, okay, and give me the answer in comment box. So in this way we just complete this exercise, this practice set. So I hope you understand this all. Okay, if you have the queries, you can ask me in, at any time in the comment box, okay, so that I can reply you. And if you forgot to subscribe the channel, so please subscribe the channel so that you can easily find out the next video in this series. Okay, thank you for this.